Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the paper 2 exam for May-June 2020 variant 1. So let's get started. Question 1 says a pendulum makes 50 complete swings in 20 minutes and 40 seconds. What is the time period of one complete swing? So the total time is 2 minutes makes 120 seconds plus 40 seconds. And we divide the total time by 50 complete oscillations. That gives us a 3.2 second periodic time. So the answer is B. Question 2 says a student investigates the motion of a ball rolling down a slope. The diagram shows the speed v of the ball at different times t. So we have 0, 0.2 seconds, 0.4 seconds, 0.6 seconds. That is a step of 0.2 seconds every time. The first time it increased from 0 to 2.8, the second time from 2.8 to 5.1, the third time from 5.1 to 7, and it asks which statement describes the motion of the ball. Is the acceleration not constant? Acceleration is negative, speed is decreasing, velocity is constant. First of all, the speed is not decreasing and the velocity is not constant since the direction of motion keeps changing and the magnitude of the speed keeps changing. Acceleration is negative means that it is decelerating, but in this case it is accelerating, so the only option is option A, where it says that the acceleration is not constant. And actually if you use acceleration equals v minus u over t for each step, that is 3 times here, you will find that the acceleration it will not be constant. Question 3 says, which statement about acceleration is correct? It is related to the changing speed of an object. Yes, it is, but we read the other sentences. It is distance an object travels in 1 second, that is speed. It is a force acting on an object divided by distance. No. It is a force acting on an object when it is near the earth. Also no, so the answer is A. Question 4 says, which statement correctly describes the effects of placing a heavy load in a car? It is easier to accelerate the car and easier to bring it to rest. No. It is easier to accelerate the car but more difficult to bring it to rest. No. It is more difficult to accelerate and more difficult to bring to rest. Yes, this is the correct sentence. So it is C. Question 5 says, a mass of 6 kilograms rests on the surface of a planet. On this planet, G equals 20 newtons per kilogram. So we have M and we have G, and we are required to calculate the weight. Weight equals mg, so it is 6 multiplied by 20. That gives us an answer of 120 newtons. Question 6 says the mass of a measuring cylinder is 190 grams. 400 centimeter cubed of liquid is put into the measuring cylinder. The total mass of the measuring cylinder and the liquid is 560 grams. 4 solid objects are lowered in turn into the liquid. The density of the objects are shown. One has density 0.4, 0.9, the other have 1.2 and 2.7 grams per centimeter cubed. And we are required to know which objects will float. So this density must be less than the density of the liquid. So first we calculate the density of the liquid. So we calculate the mass of the liquid by subtracting the masses, 560 minus 190. Then we divide by the volume of the liquid, which is 400 centimeter cubed. This gives a density of 0.925 grams per centimeter cubed. So we have the 0.4 and the 0.9. So only 1 and 2 will float. Question 7 says the diagram shows a wooden beam PQ of negligible weight, which is attached to a wall by a hinge at P and kept in horizontal position by a vertical rope attached at Q. So we have a vertical force here. We can call it F. The beam is 3 meters in length. A man of weight 800 newtons walks along the beam from P to Q. So we have a weight of the man acting here, 800 newtons. What is the distance of the man P when the tension in the rope Q becomes equal to 500 newton? So we have this equal to 500 newton, and this whole distance from P to Q is 3.0 meters, and we want to know the distance of the 800 Newton force from P. when the beam is in equilibrium. So we use clockwise moments equal anti-clockwise moments. The clockwise moment of the man is 800 times the unknown distance d, and the anti-clockwise moment of the rope is 500 newtons multiplied by the distance 3. So we divide 500 times 3 divided by 800, and that gives us a distance of 1.875, which we can approximate to 1.9. So the answer is C. Question 8 says, which quantity is a vector quantity? Acceleration is a vector quantity, so it's the first one. Distance, speed, and mass are all scalars. Question 9 says, an object of mass 1.2 kilograms is moving with a velocity of 2 meters per second. When it is acted on by a force of 4 newtons, the velocity of the object increases to 5 meters per second. So we have mass, and we have initial velocity, we have final velocity, and we have force. And we are required to know for how long the force acts. We need time. So adding these together, we can use the equation of force multiplied by time is equal to the change in momentum, or equals to mass times change in velocity. Then we substitute 4 Newton multiplied by the unknown time t is equal to the mass 1.2 multiplied by final velocity is 5 minus initial velocity is 4. Then we divide by 4 on the other side, leaving t the subject of the formula. This gives an answer of 0.90 seconds, so the answer is A. Question 10 says, the diagram shows part of a roller coaster ride with the car at different positions. The car runs freely down from position X to position Y and up the hill on the other side. What happens to the kinetic energy and the gravitational potential energy of the car as it moves from X to Y? So we are going down, so the gravitational potential energy most definitely decreases, and the kinetic energy increases under gravity. So the answer is C. Question 11 says, which energy resource does not have the sun as the original source? Coal, geothermal, hydroelectric, and wind. So we have geothermal. Only 2 sources of energy are independent of the sun. These are geothermal and nuclear energy. Question 12 says, the diagram shows a solid block resting on a bench. The dimensions of the block are shown. It's 40 by 20 by 80. And we have different faces, P, Q, R. On which labeled surface should the block rest to produce the smallest pressure? Smallest pressure means the largest area. Since the weight, which is the force, is the same, so we need a larger area to create a smaller pressure. So the largest area would be 80 multiplied by 40. This 40 can be the side on this part, so it is face P. So the answer is A. Question 13 says, the pressure due to the liquid on an object immersed in that liquid is 4,500 Pascal. The density of the liquid is 900 kilogram per meter cubed. What is the depth of the object, that's H, below the surface of the liquid? We can use the equation P equals rho G H. Pressure is 4,500, the density is 900, G is 9.8. Of course, in that year it was 10 meter per second squared. And we are required to calculate H, so we move these to the other side by division. That would give an approximate number of 0.51 meters. But the required answer is in centimeters, so we multiply this by 100. It would be 51 centimeters, so the closest number is 50 centimeters. Question 14 says, a gas is heated in a sealed container. The volume of the container does not change. What happens to the molecules of the gas? The average distance between molecules increases. No, because the volume is constant. The average kinetic energy of the molecules increases. Yes, because it says heated. As temperature increases, the kinetic energy of molecules increases. So this is the answer. The mass of each molecule does not change. The volume of each molecule does not change. Question 15 says, water in a beaker evaporates when left on a bench for a period of time. Which 3 factors all affect the rate of evaporation of the water? Wind speed, surface area, and temperature. Yes, these all affect the rate of evaporation. In the second part, volume does not affect, volume does not affect, temperature, volume does not affect, so it's A. Question 16 says a solid is heated, causing it to expand. What effect does this have on its mass and on its density? So the mass does not change, the mass always stays the same, and as you heat something and it expands, the volume increases and the density is inversely proportional to volume. So as volume increases, the density decreases, so the answer is C. The next question says the diagrams show 4 blocks of steel, same material. The blocks are all drawn to same scale. The same quantity of thermal energy is given to each block. Which block shows the greatest rise in temperature? So using the equation Q equals mc delta theta, we have C and Q the same. Q same amount of thermal energy, C is the same for the same metal, which was steel. This means that as mass increases, the rise in temperature decreases, and vice versa. So for the largest temperature rise, we need the smallest mass, which is in block A. Question 18 says, why are metals better thermal conductors than other solids? Metals contain free electrons, which help transfer the energy. That's correct. Molecules in metals are in fixed positions. No. Molecules in metals can move freely. No. Molecules in metals vibrate faster than those in other solids. No. So the answer is A. In question 19 it says two freezers X and Y are identical except that one has a door opening at the front and the other has a door opening at the top. Both doors are the same size and are opened for the same amount of time. Which freezer gains the least amount of thermal energy? Least amount of thermal energy means that it did not gain enough heat, or it did not get much heat from the outside or the surroundings. So first of all, cold air falls or warm air falls. Cold air falls. So we don't have B or D. Then which one would cause air to fall easier? Is it X or is it Y? X will cause the air to fall easier, then more hot air will go inside. So this would heat up much quicker. So the answer for the smallest amount of heat gained is Y. So the answer is C. Question 20 says a wave of frequency 6,600 Hertz travels 1,320 meters in 4 seconds. What is the wavelength of the wave? The wavelength is equal to speed over frequency. But to calculate speed, speed equals distance over time, which is 1,320 over 4. That gives a speed of 330 meters per second. Then we divide 330 by the frequency, which is 6,600 Hertz. That gives a value of 0.05 meters. Question 21 says the diagram shows a wave. What are the amplitude and the wavelength of the wave? So this is not the amplitude, this is double the amplitude. The amplitude is 3 centimeters from the equilibrium position or the undisturbed position to a crest or to a trough. And the wavelength is between two corresponding points, two identical points like a crest and a crest. So the wavelength is 8 centimeters. So we have amplitude 3 and wavelength 8. The answer is B. The next question says, which statement is correct? The speed of light in glass is equal to the speed of light in a vacuum. No, it's less. The incident angle of light of a light ray at an air glass surface is the angle between the ray and the glass surface. No, it's between the ray and the normal. The sine of the critical angle at an air glass surface is equal to 1 over the refractive index of glass. That is correct. The angle of refraction for light passing through an air glass surface is proportional to the angle of incidence at that surface. No, it is the sines of the angles that are proportional, not the angles themselves. So the sine of the angle in air is proportional to the sine of the angle in the medium, not the angles themselves. Question 23 says a narrow beam of white light passes through a prism and is dispersed into a spectrum. Which row is correct? You should know that red has the smallest deflection and violet has the greatest deflection. So 1 would be closer to red or red, and 3 would be closer to violet or violet. So now color 1 should be red, and color 3 should be blue. So there is only one blue here, so the answer is C, and yellow is in the middle, so we have no problems. Question 24 says, an intruder alarm sensor detects that a person is warmer than his surroundings. Which type of electromagnetic wave does the sensor detect? For heat, we have infrared radiation. Question 25 says, sound travels through air as a series of compressions and rarefactions. Which statement correctly compares a compression with a rarefaction? In a compression, the wavelength is longer, no. In a compression, the wavelength is shorter, no. In a compression, the density of the air is greater, yes, than in a rarefaction, because molecules are closer in a compression, so the answer is C. In question 26, it says 4 nails A, B, C, and D are tested to find which makes the strongest permanent magnet. One of these nails is placed against a bar magnet, and the number of paper clips which the nail can support is recorded. The bar magnet is then removed, and the number of paper clips remaining attached to the nail is recorded. Each nail is tested individually. Which nail becomes the strongest permanent magnet? So for strongest, we need the largest numbers. So A and B are omitted. Permanent magnet means after removing, you need a large number, so the answer is C. Question 27 says, the circuit shows one method of magnetizing a steel bar. How can the circuit be altered so that it can be used to demagnetize the magnetized steel bar? The best method to demagnetize a magnet is moving the magnet through a solenoid connected to an AC supply. So we see the choices here. Remove the steel bar from the coil while the current is switched on. Replace DC supply with an AC supply, that's correct. And gradually reduce the supply voltage to 0. That's similar to removing the magnet or moving the magnet through the coil then outside, so the answer is B. Reversing the polarity only reverses the polarity of the magnet. Same with D. Question 28 says, a student uses the circuit shown to determine the resistance of two identical resistors. The voltmeter reading is 2.2 volts. That's the total voltage across the two resistors, and the meter reading measures the total current of 0.25 ampere. We are required to know each resistance of the two resistors. We can first calculate the total resistance using R equals V over I. So we divide 2.2 over 0.25. That gives a total resistance of 8.8 ohms. But that's for two identical resistors in series. So if we name them X and X, so X plus X or 2X is equal to 8.8. So X equals 8.8 over 2, which gives 4.4 ohms, making the answer C. In question 29, it says an electric fire is connected to a 240 volt supply and transfers energy at a rate of 1 kilowatt. How much charge passes through the fire in 1 hour? First, relating charge to voltage, we have the equation energy equals VQ. Energy equals to potential difference or voltage multiplied by charge. And energy is also equal to power multiplied by time. So first we can calculate the energy equals to 1 kilo, which is 1000, multiplied by the time in seconds. 1 hour is 60 minutes multiplied by 60 seconds. So here we have 3,600,000 joules of energy, or 3.6 times 10 to the power of 6. Then we use this equation and we say that 3.6 times 10 to the power of 6 is equal to the potential difference, which is 240 multiplied by the charge Q. Then we divide by 240. That gives 15,000 coulombs, which is 1.5 times 10 to the power of 4. So the answer is C. Question 30 says the diagram shows an incomplete circuit. The temperature and light levels around the circuit remain unchanged. 4 electrical components are connected in turn across PQ. The cell is reversed and the 4 electrical components are connected again in turn across PQ. For which component is there a significant change in the magnitude of the current? So the light dependent resistor and the thermistor would not affect the current if the temperature and light are unchanged, and the resistor would simply give the same amount of current. But a diode would give current in one polarity and would not give any current in the opposite or the reverse polarity. So one would give a significant current and the other would give zero current. So that's the one that would cause a change, a significant change in the magnitude of the current. So the answer is A. In question 31, it says in the circuit shown, A1 and A2 are ammeters. Switch S is closed. It was open at first, then it is closed. So now we have more resistors in parallel. Which row is correct? The resistance of the whole circuit decreases or increases. When you add the resistors in parallel, you actually decrease the resistance, which causes the current to increase in the circuit as a whole. So A1 and A2 are connected to the battery or measure the total current in the circuit. So if one of them increases, the other must increase. So the answer is B. Question 32 is about logic gates, also question 33. So you can skip those two questions because they are not in the new syllabus, but I will solve them anyway. Which symbol represents an OR gate? That is A. In question 33 says a digital circuit consists of two logic gates. When the input of the circuit is 1 and 1, the output is 0. Which combination of logic gates gives the result? So we just use a trial and error. If you enter 1 and 1 to an AND gate, you get 1, but to an AND gate, you get 0. Then it gets reversed to 1. So this is not the answer. 1 entering a NOT gate, you get 0, and 1 to an OR gate. So 1 and 0 to an OR gate, you get 1. So this is not the answer. Choice C, 1 and 1 to an AND gate, you get 1. Then you reverse it through a NOT gate, you get 0. So this is the answer, C. Question 34 says the diagram shows a wire between the poles of a magnet. The wire is perpendicular to the page. The wire is moved and a current is induced upward out of the paper. In which direction is the wire moved? In this case, we use the right hand rule. So if you point downwards with your index finger towards a magnetic field from north to south, and you are required to induce a current out of the page, so the middle finger should be pointing away from the screen, then you would find that the thumb is pointing to the left, so the wire must be moved to the left. So in the choices, we choose B, which is right to left. Question 35 says a 100% efficient transformer converts 240 volts input voltage to 12 volts output voltage. The output power of the transformer can be a maximum of 20 watts. The output is connected to two 0.30 ampere bulbs in parallel. So if you connect the secondary coil of the transformer to two bulbs with each of current 0.30, you have a total current in the secondary coil of 0.60. That's 0.30 plus 0.30. So the current in the secondary coil is 0.60 amperes and the voltage in the secondary coil is 12 volts. You can use this information to calculate the current in the primary coil using the equation VPIP is equal to VSIS. Here we have 240, IP is required current, then Vs is 12 multiplied by the current 0.60. That gives you an answer of 0.03 amperes as a primary current. Now it says that one of the bulbs fails, so you no longer have a total current of 0.60 ampere in the secondary coil. Now you have 0.30 alone due to the one lamp. So the current in the secondary was divided by 2. That causes the current in the primary coil also to be divided by 2. So the new current in the primary coil is 0.015 amperes. Now we check the answers. In the primary coil, the current decreases by 0.30. No, it decreases by 0.015. Yes, it does not increase. It does not remain unchanged. Since the current in the secondary coil changed, the current in the primary coil also changes proportional to each other. The voltage also remain with the same ratio. Question 36 says cables transmit electrical power from the output of the transformer at a power station to the input of a transformer at a substation. The power at the output of the transformer at the power station is 400 megawatt. Which situation delivers the most power to the input of the transformer of the substation? Technically, the question is asking which method would cause less energy losses or less power losses. So the power losses are minimized when you use high voltage. For stepping up, when you step up the voltage, the current decreases, which decreases heating effect. And the diameter of the cables affects the resistance. If you use the equation power loss is equal to I squared R, so as I increases or R increases, power increases. So you need to decrease current. We did that by stepping up the voltage, and you decrease resistance by using a large diameter wire. So the answer would be C. Question 37 says uranium-235 is a radioactive isotope. It undergoes a chain of decays and eventually forms the stable isotope lead-207. These two isotopes are represented as shown. During this chain of decay, how many protons and how many neutrons are lost from a single nucleus of uranium-235 to form a single nucleus of lead-207? So the easy part is protons. From 92 to 82, you lost 10 protons. The hard part is nucleons. From 235 to 207, you lost 28 nucleons, not neutrons. The nucleons are the total of protons and neutrons. So you already lost 10 protons. You subtract that, you get the neutrons, which is 18. So the answer is A. Question 38 says a radioactive material has a half-life of 20 days. A sample of the material contains 8 times 10 to the power of 10 atoms. How many atomic nuclei have decayed, not remaining, after 60 days? Since you have the half-life and you have the total time, you can divide the total time by the half-life. 60 divided by 20 to know how many half-lives have passed. That's 3 half-lives. This means that the original number of atoms, you keep dividing it by 2, 3 times. You started from 8, divide by 2, you get 4, divide by 2 a second time, you get 2. The last time you get 1 times 10 to the power of 10 atoms that remain. So the decayed would be 8 minus 1, which gives you 7 times 10 to the power of 10 atoms that decayed, and the remaining were 1 times 10 to the power of 10 atoms. Question 39 says a thin sheet of paper is placed between a radioactive source and a radiation detector. The count rate falls to a very low reading, which is background. From this result, which type of radiation is the source emitted? The only one that can be stopped by paper is the alpha particles. None of the others can be stopped by a piece of paper. So the answer is A. The last question says alpha particles, beta particles, and gamma rays are emitted by radioactive nuclei when they decay. Which emissions can be deflected by an electric field? They need to have a charge, so only alpha particles and beta particles, which are positively and negatively charged respectively, can be deflected in an electric field. Gamma rays cannot be deflected by electric fields. So this was the end of the exam. I hope you found this video useful, and I will see you in another video.